minimum, maximum, and minimum values. Okay, so first of all, there's a difference between absolute and local. So absolute means it's the, so like an absolute minimum, there's maximum and minimum also. Okay, so absolute minimum, it'd be the smallest value on the entire, so minimum means the smallest value. No, wait. Minimum is the smallest value. Absolute means on the entire domain of F. Okay, and then again, let me see, local means when X is near C. Okay, and again, minimum still means the smallest function value, smallest value. The smallest value is what it is. Okay, so this one be, the answer to that one would be the second one. The other ones don't make any sense. Let's talk a little bit more about that. So to have a local, we'll talk about local, okay? Because minimum and maximum, that means high and low. What you have to have there is like a local, this would be a local maximum right there, okay? And then that would be a local minimum, okay? Even though there's points that are here that are higher and there's points that are lower, this would be the local maximum, and then this is the local minimum. So that's what you're kind of looking at. It has to be, for it to be a local something, it has to be at an interior point. So like, for example, if your domain is, if your domain's like that, this goes from here to here, then this is not these are not local. That's not a local minimum. That's not a local maximum, okay? This is what you would call absolute maximum. But it's not local. So the local has to, because it has to be at an interior point. Okay, since it's not at an interior point, that can't be, and likewise, this one can't be a local minimum either, because it has to be at an interior point. Now this are local. This would be a local maximum, and this would be a local minimum right here, because those are at interior points inside the interval. Okay, now one thing is if F has a local minimum or maximum at C, and if the derivative exists, then that derivative has to be 0. Okay, and this is really important. So like if you look at these right here, if you look at these derivatives here, right here, there's a local maximum. The slope of the tangent line is 0, so the derivative is 0. Same thing here, the slope of the tangent line is 0, so the derivative is 0, and right there too. Okay, and there, those slopes are 0, those derivatives are 0. Okay, that's if the derivative exists. Okay, now you could have a situation like this, where it comes up like that and then does that. Okay, here the derivative is not 0. This is a local maximum. F prime of C does not exist. Okay, it's not 0, but it just doesn't exist though. Okay, so that's just if the derivative exists, then it has to be 0. Okay. Another situation could be where you've got, it goes like that, and then it's down like there. You got a function like that. So that's a local maximum, and the derivative doesn't exist. Again, okay? because it's not continuous. It's not even continuous. Okay, there's a break in it. Okay, and so this brings us to the next definition that we need to think about, and that is critical numbers. Okay, and that's where the derivative is 0 or does not exist. Okay, that's what critical numbers are. And those so like if you have a function and you want to know, you want to find local minimums and local maximums, then what you can do is take the derivative and see where it's 0 and see where it doesn't exist. And those are all of your candidates for all of your local maximums and minimums has to satisfy one or the other of these. Okay, that's another way of saying this statement right here. If it's a local minimum or maximum, then the derivative is 0 or it doesn't exist. Okay, let's do some more examples. Number 2. So here, use the graph to state the absolute local maximum and minimum values of the function. Okay, so the values, those are y values. Those are just the y values. Okay, and so this is the highest point on the graph. So this 5 is the absolute maximum value, because that's the highest point on the graph. Okay, absolute minimum value. Here, this part is lower than anything, but it doesn't actually attain the 1. Okay, and so this is kind of an interesting situation. There's an open circle here, meaning that the function is not 1 right here. And if you want to go greater than 1, that's not going to be the absolute minimum either. Anything greater than 1 is not going to be absolute minimum, because you always can find something in between that number and 1 that's on the graph right here. So that means the absolute minimum value does not exist. Okay, so write DNE for does not exist. Okay, local maximum values. Okay, so those are going to be at interior points. This is 1. That's also 1. Let me do this in a different color. So local. That's still going to be 1 right there, because it's right here. This is not going to work out because the value is right here actually. Okay, so it's these two values, 5 and 4, or 4 and 5. Then finally, we have local minimum value. Okay, so those will be right here. Here is going to be 1. There's going to be 1, and those are both 2, right? And this is 3. So 2 and 3. Okay. Any question about that?
Yeah. So for the 2, would that be considered an interior angle still on the y-axis?
Oh, you're right. You're right. Okay, I made a mistake there. This is not you're right. This is not a interior point, so that's not a local minimum right there.
And then,
but this one is.
More. So for the point at 1, 3, it has the circle, the open circle on the line, but then it's got that offset point. That wouldn't be considered a value because it's not a part of the line.
Well, because it's not higher than the points around it.
Oh, gotcha. Yeah, that makes sense.
Actually, you know what? This is a local minimum. This is a local minimum because it's lower than the points around it. That's kind of weird because it's lower than these points here. So like you can have this interval, you can take that interval there, and everything in here is higher than that point. So that's a local minimum. So that's interesting. I discovered a couple of new things. Thanks for asking about that. That's very helpful. Okay, number 3. Sketch the graph of a function f that is continuous on 1 to 5. So from 1 to 5 is continuous. Okay, those are all continuous. Those are all continuous. Yeah, so we're all doing good there. The next thing is it has an absolute maximum at 2. Absolute maximum at 2. Okay, so here's 2. Let's see here. Is that? Yeah, that seems to be higher than there. That's fine. This is lower. So this is no, it doesn't have an absolute maximum at 2 because this is higher right here than that point at 2. Here, this one's fine. This is the highest point, and then this is the highest point too, right? So we're good. Okay, absolute minimum at 5. Okay, so here's 5. And that's not a minimum. That's not an absolute minimum, so that can't be it. So that grabs out. This one is fine, and this one, wait, this one is lower than this, right? Yeah, that's lower than that. This one is not, this is lower than that, so that can't be. Okay, so we got to pretty much have it then. But let's just look at the last thing. The last condition is 4 is a critical number, but there's no local maximum or minimum there. Okay, so at 4, we have, remember, critical number was the derivative has to be 0 or the derivative does not exist. That's what critical number means. Okay, so for 4. And so at 4 here, the slope is, so the derivative is, the slope is 0, so that's because it's a horizontal tangent, and so the derivative is 0. Okay, so this is a critical number there. This would be a critical number. This is a critical number, but it's a local minimum. Okay, so notice that all local minimums or maximums have to be at critical numbers. However, just because it's a critical number does not mean it's going to be a local maximum or minimum, like in this case right here, because it flattened out and the slope went to 0, but then it decided to go back down to, decided to descend further after that. So it's not a local maximum or minimum. Okay, so this would be the answer. Okay, let's go to number 4. Sketch the graph of f of x equals 3 over x. Okay, so that's going to look like this. And this is just for x greater than or equal to 3, because you'll have another part over here, but x greater than or equal to 3. So basically, it's just going to be, I'm going to erase this. It's just going to be from here on over is the graph. Okay, so the absolute maximum value is going to happen when x equals 3. So f of 3 is 3 over 3. So replace that x with a 3, so we get 1. That's going to be your absolute maximum value. Okay, absolute minimum value, this keeps on going down to 0. It never hits 0 though. So that's why this does not exist. Okay, local maximum values, they're not going to be any of those either. And there's going to be no local minimum value either. Okay, any question on that? Okay, number 5, sketch the graph of f of x equals 4 cosine t between negative 3 pi over 2 to 3 pi over 2. Okay, so cosine starts up here, and since it's 4 cosine, it's going to be at 4. And it goes down to 0 when it's at pi over 2. And negative pi over 2, like that. Then it goes down to negative 1 when it hits pi. And it goes back to 0 it says we're only going to go to 3 pi over 2, so let's just have it stop right there. And again, over here, I'll do the same thing. So that's negative pi, and that's negative 3 pi over 2. Okay, so from there to there. Okay, so that's what the graph's going to look like. Okay, use your sketch to find the absolute and local maximum and minimum values of f. Okay, so the absolute maximum value is 4. Okay, so the value is 4. It occurs when x equals 0, or t is 0. Okay, absolute minimum value, okay, that one is going to be these two values here, which are negative 4. Okay, local minimum value, or no, I'm sorry, local maximum would be 4, because we're right up here. And the local minimum value is, again, these are also local minimum values, also so negative 4. Okay. Any question about that? Okay, number 6, find the critical numbers of this function. Okay, so remember, critical numbers means that the derivative is 0 or the derivative does not exist. Okay, this is a polynomial, so derivatives exist everywhere, so that's not going to happen here. So we just need to find where the derivative is 0. So there's this new game that you guys are going to be playing a lot, which is take the derivative and set it equal to 0. So the derivative of x cubed is 3x squared. Derivative of this is going to be 6x. Okay, the 2 comes down. 2 times 3 is 6. This reduces by 1, and then this is going to be minus 24. Okay, you set that equal to 0. You can factor 3 out. So you get x squared plus 2x minus 8. Okay, and then this right here factors, I believe. Yeah, this will factor into plus 4 and minus 2. Okay, all that factors into that. And this one gives you negative 4, and this gives you 2. Okay, so negative 4 and 2 are going to be the critical numbers. Okay, let's try number 7. Find the critical numbers of this. Again, it's where the derivative is 0 or it doesn't exist. Okay, so we'll take the derivative. Okay, this is going to be the product rule. So the derivative of the first one is 4/5. X, okay, 4/5 minus 1 is negative 1/5. Okay, times the second one plus the first one. So the first term here, the first term there, times the derivative of this one. Okay, this 2 is going to come down. This drops to the first power, which is just like we don't write any power at all. And then multiply the derivative inside. The derivative inside is just 1. Okay, the derivative of x is 1, the derivative of negative 3 is 0. That's just 1. Okay, I'm going to, let's see, I think the easiest thing would be factor out a 1 over 5x to the 1/5. Yeah. So that's this 5 and this x to the minus 1/5. You can factor that out of everything. Okay, and so then here we're going to be left with 4 times this squared. Okay, that squared is x squared minus 6x plus 9. And then here, this is going to become x. And then there's 5 also. And we still have this 2, and then it's x minus 3. Okay. Okay, so this is 4x squared minus 24x plus 4 times 9 is 36. Okay, and then this is 5 times 2 is 10. So that's 10x squared minus 30x, 30x. Dang, I think I probably should have been more careful with that. Hopefully, I don't get any major mistakes. Okay, so 4x squared plus 10x squared is 14x squared. Then this and this is minus, 54x, what? 36. Okay, this is looking really weird. I guess I can factor 2 out. And that's 7x squared minus 27x plus 18. Okay. Okay, so now I'm going to try to factor this. Hey, that works. Okay, because like 7 times, okay, so 7x times x is 7x squared. The last one's product is positive 18, so it's negative 6 and negative 3 is positive 18. The outside is negative 21x, inside is negative 6x. So negative 21 minus 6 is negative 27x. So there we go. Okay, now we can go ahead and just write these down, the critical numbers. So this one, because this is in the denominator, that means 0 is a critical number. Because 0 gives you a 0 in the denominator, which makes the derivative doesn't, this one doesn't exist. This derivative doesn't exist. 0 doesn't exist. Okay, and then the other two are here. If you solve this, you get 6 over 7. And then this one gives you 3. Okay, so for those ones, the derivative is 0 for those two. Okay. Okay, any questions about that? Okay, great. Let's move on to the next one. Number 8. Okay, now here, when it says find the absolute maximum and absolute minimum, the pattern of how you're going to solve this is, so the outline of what we're supposed to do is find all critical numbers and endpoints. Okay, and then what you're going to do is calculate f of x at all, f of c at all of these. Okay, and then finally the highest, or I should say largest, that's probably not a good idea to say highest. So largest value is the absolute maximum, and the smallest is the absolute minimum. Okay, so find all critical numbers and endpoints, and then calculate this function at each of those. The largest is the absolute maximum, the smallest one is the absolute minimum. Okay, so let's go ahead and do that. And so what we'll do is we'll say that all of these are, let's call those candidates. And we can make a list here. So these are candidates. Let me do this. And then we'll calculate the values at that. So we have endpoints that are -2 and 3. Okay, those endpoints are always going to be candidates. Okay, so that and that. There. Okay, so now also we will calculate the derivative and find out where the derivative doesn't exist and where it's 0. The derivative exists everywhere for this function here, because it's a polynomial. So we're only going to be looking where the derivative is 0. So I bring the 3 down, that gives you 12x squared. Derivative of this, bring the 2 down, that's -12. And then x squared drops to an x, and then -24. And then the derivative of 1 is just 0. Okay, so that means we can factor 12 out, and we get x squared minus x minus 2 equals 0. We'll set that equal to 0. And this factors into x minus 2 and x plus 1. So that gives you 2 and -1. So those are 2 more values. Check that the 2 and -1 are both in the interval. They're both in this interval here. If either of those is outside the interval, then you throw them out. Just they don't go to the next step. Okay, since they're both inside the interval. Okay, because like let me just show you. Okay, so here's 3, here's -2. Okay, -1 would be right here, and 2 would be over here. Okay, so those are inside. Okay, so -1 and 2. Those are all your candidates. Now what we do is we calculate the function at those values. So okay, so I plug a -2 into here, so that's going to be 4 times -2 cubed minus 6 times -2 squared minus 24 times -2. Whoa, looks like we need more space. Okay, let me just make more space here, I guess. Plus 1. So let's say this is -8 times 4. That's -32 plus 4 times 6 is, no, that's also minus. -24, whoa. Oh, but this one is plus 48 plus 1. Okay, so that one gives you -7, is what I got. Okay, now f of 3, so plug a 3 in, so that's 4 times 3 cubed minus 6 times 3 squared minus 24 times 3 plus 1. So this is 27 times 4, which is 108, minus, let's see, 6 times 9 is 54, minus, okay, 24 times 3, 72, plus 1. Okay, so 108 minus 54. Okay, that gives us negative 17. Okay, then negative 1. So that's going to be negative 4 minus 6 plus 24 plus 1. Looks like 15. And then putting a 2 in, you got 4 times 2 cubed minus 6 times 2 squared minus 24 times 2 plus 1. So that looks like 4 times 8, that's 32. Minus 6 times 4 is 24. Minus 48 plus 1. And that's negative 39. Okay, so now the largest out of these 4 numbers, out of those 4 numbers, the largest is your absolute maximum. And that's going to be 15, because 15 is larger than all of the others. And the smallest out of all these 4 numbers, which is negative 39, is going to be your absolute minimum. Okay, so your absolute minimum is negative 39, absolute maximum is 15. Okay, so that's so again, let's go through, let me just run through that I followed the outline. First step was to find all critical numbers and endpoints. These first 2 are endpoints, just get those off of here. I set the derivative equal to 0. Also, in this case, since it's a polynomial, you don't have any places where the derivative doesn't exist. But if it doesn't exist somewhere, then you need to put those values down as well that are inside this interval. Okay, and then so then I found where the derivative is 0, which is at those 2 points. Those are both inside the interval, so they go over here as well. Calculate the values at all of them, and it happened at these 2 right here. This is the lowest out of all, lower than those ones. This is the highest of all, it's higher than all 3 other ones. So those are the absolute minimum and maximum. Those are the values. Okay, now there's also the question of where they happen, and in this case, the absolute maximum happens when x is negative 1. The absolute minimum happens when x is 2. Some textbooks will say that the absolute maximum is the point negative 1, 15. Okay, that could be another possible for some textbooks. And the absolute minimum would be 2 comma negative 39, would be that point, would be these points, or the absolute maximum minimum. Okay, but for this book, it's just the y value. Okay, let's do another one of those, number 9. Okay, absolute minimum values of this function on the interval from 0 to pi over 2. There's supposed to be a comma between those. Okay. So over here, we're going to make the candidates. And then we'll have f of t, f of whatever it is. And so, of course, the endpoints go down as the first candidates, 0 and pi over 2. Okay, now let's see if we can find any other critical points that are, or critical numbers that are inside the interval from 0 to pi over 2. So this is a trigonometric function. So the derivative, let me do a different color. So that means that the derivative, well, it's just cosines and sines, right? So the derivative is going to exist everywhere. So there's no places where the derivative doesn't exist. There's not going to be any critical numbers coming from that. Okay, so the derivative of 2 cosine t is negative 2 sine t. The derivative of sine t is, or sine 2t, is cosine 2t times the derivative of 2t, which is 2. So put the 2 out there. So this is the derivative there. Okay, now I'm going to use a trig identity. Cosine of 2t is equal to 1 minus sine squared t. I chose this one because this actually has 3 of them. Wait, 1 minus 2 sine 2t, sine squared t. This actually has 3 different versions. One of them is cosine squared minus sine squared. The other one is cosine squared, 2 cosine squared minus 1. But I use this one because this is a sine right here. Okay, I'm just going to plug that into here. Okay, so this becomes negative 2 sine t plus 2 times, and again, it's just going to plug in there. And I'm going to go ahead and set that equal to 0. Okay, now let me distribute the 2. Put this out. I'm going to lead off with that one. And I'm going to factor a negative 2 out. Okay, so factoring a negative 2 out of there, leaves this as a positive sine t. Factoring a negative 2 out here leaves it as a negative 1. And then, of course, out of here leaves it as a 2. Okay, so this is really not important at all at this point. But this right here, of course, sine squared t is sine t times sine t, right? And so sine t times 2 sine t will be 2 sine squared t. And then if I put a plus 1 there and a minus 1 there, I think that does it. Yeah, so when I multiply this out, I get this. Okay, so that's setting equal to 0. So I'm going to take, so this gives me sine t equals 1/2. And this gives me sine t equals negative 1. Okay, in this interval from 0 to pi over 2, this is going to happen when t is pi over 6. Okay, because with the pi over 6 angle, if that's pi over 6, then that's 1. Then you could write. Then this is the ratio of the 3 sides: 1, 2, 3. So the sine is 1 over 2. Okay. So sine of pi over 6 is 1 over 2, 1/2. Okay. So that's the only angle between 0 and pi over 2 that does that. And then this one, when the sine is 0, it has to be an angle that's pointing down this way, and there's none of those that are between 0 and pi over 2, because 0 to pi over 2 is all this, right? Is all these angles up here in the first quadrant. So none of those is going to work. Okay, so let's go ahead and, so that means that we're going to add pi over 6 as the candidate. Okay, and now what you do is you use the original function to calculate what the value at each of these points. Okay, so if we put a 0 in here, we get 2 cosine 0 plus, well, how'd that happen? Plus sine of 0. So this is 1, and that's 0, so that's 2. Okay, if we put a pi over 2 in, we get 2 cosine of pi over 2 plus sine of pi. Okay, that's 0. That's cosine of pi over 2 is, oh, that's also 0. So this is going to be 0. Okay, and then this last one, we have 2 cosine of pi over 6. Again, putting pi over 6 in here, putting pi over 6. Putting pi over 6 in here is going to give us pi over 3 plus sine of pi over 3. So let me draw a pi over 3 angle. So if that's pi over 3, then the ratios can be 1, 2, root 3 like that. Okay, cosine of pi over 6 will be root 3 over 2. And sine of pi over 3 will be root 3 over 2. Okay, so this is 2 of these plus another one of these, another root 3 over 2, gives you 3 root 3 over 2. Okay, so that value there. Okay, now the question is which, so now we go to the, we come to the final step, okay, which is which value is the smallest of all these three? Is not the 0, right? This is the smallest. Okay. So that means that the absolute minimum is 0. Okay, and then we have the question of which is the largest. And it turns out this is a little bit larger than 2. I mean, you can like verify this on the calculator, or I could verify that on the calculator. See here, 3 times the square root of 3, all divided by 2. That's this is approximately 2.598, which is greater than 2. So this is the largest. Okay, so absolute maximum is going to be 3 root 3 over 2. Again, when you're doing these kind of problems, don't write down the approximation because it will just be wrong. Webassign will mark it wrong. Okay, and we'll give you negative feedback, and hopefully you'll remember that negative feedback for when you take the exam, so you don't do that. So this is an approximation. It's not the exact answer. In fact, even if you took this out like a billion decimal places, it's still going to be approximation. It's not the exact answer. This is the exact answer right here. So that's what Webassign wants you to put in.